Everyone is hearing?
Yes.
Yeah, so
Yes, I am.
all right, good. Yeah, so we're just pick up where they left off the last class. I think we did reach right here at microprocessor. All right. So as I said, a microprocessor is an integrated circuit capable of analyzing data and calculating appropriate outputs. Uses the binary number system to make decision, comparison, or calculation. Compares input signal to memory data to decide what the output should be for maximum efficiency. So as I always say, everything with the computer, it always have something that it is making reference to. So as we stated at the last bullet right there, it said compares input signal to memory data. So that a data we have stored inside by the manufacturer, it is measuring against that data to see what adjustment need to be made. And as I always say, use a binary number system. I will know what that is. What are binary numbers?
Zeros.
Hello?
Yeah, I'm hearing you.
Yeah, I spoke to Mr. Beswick about recording the sessions. I don't know because I can't see it on my phone. I don't know if I need to have something or the host need to give permission to record the sessions for each person who want to record.
Oh, but you're seeing the screen though?
Yeah, I'm seeing the screen.
Oh, but your device not screen recording?
You mean I was wondering if it can be done from in the Zoom itself, or I have to do it from my phone.
Oh, well, I know the host can actually record it, but I'm not sure if the students have the
I'm already
privilege.
recording. Hi, good night. I'm already
Night.
recording. Can you hear me?
Yeah, I'm not hearing you.
All right, so I'm saying I'm already recording the session. When Mr. Ezra asked, take the recording. So for now, just focus on the class. At least we'll have a recording.
Or I will have a recording at some time after.
Once Mr. Bezos
Okay.
tells me to send it to you, I will.
I'm not hearing what you said?
Once Mr. Beswick tells me to send it to you, I will.
Oh, okay. Good. All right. I just wanted to clear that up. Thank you.
No problem. So we're back to binary. What's binary? Andre was answering.
Yeah, so somebody was answering the binary question.
Yeah, I said ones and zeros.
Yeah, man. So that's so the computer actually communicate through a combination of binary numbers to make its calculation and make a decision. All right. And we use normally use logic gates to do that. So it's basically on and off switch. So based on what goes off, what go on, the computer can actually use that now for make its decision based on the logic gates, binaries. Just a second. Yeah, man, guys, sorry about that. Just have some issue with the device. Yeah, so computer data flow. So to the left we have data in or data going in, and then through the interface. And as I already said earlier, the interface is what would actually change the wave. So if it is analog, it's going to turn it into digital. No, it's going to amplify the voltage, sorry. So if it's a weak analog voltage, once it goes through the interface, it's going to amplify that voltage. So it is usable, and then it is going to be translated into digital signal and then sent to the processor. And the processor is going to share that information with the RAM, random access memory, right? And then it will send back out a result, and then it go through the output interface, which will change back that to analog signal if necessary. And that signal will go to whichever component, so that's a clock or anything else. All right, so computer memory uses gates that are capable of storing data as voltage charges. ICs inside the memory chip will hold the data until needed by the microprocessor. All right. So here we have the RAM, random access memory, read and write type memory, stores information or data temporarily. Data is erased if battery power is removed. So in other words, with the random access memory, it's like a temporary storage. All right. Then we are going to have our read-only memory. So stores permanent data that cannot be removed from memory. Contains calibration tables and lockup tables for the general make and model car. All right, and we have the programmable read-only memory. Contains permanent data that is more specific than the data stored in RAM. Engine transaxle, weight, and tire size are specifics found in the prompt. May be replaced or reprogrammed to upgrade vehicle operation. So with some vehicle, like if you change the tire size, you can actually go upon your infotainment system, that's your screen, radio display, or the center or the cluster, and actually change the tire size. So the vehicle now I actually know how to read the wheel speed, because a smaller diameter tire I can actually complete one turn before a larger diameter tire. So the computer actually needs to know these information. So with the prompt memory, you can actually go there and change those settings for proper vehicle operation. So that is just an example. And this is the erasable programmable read-only memory. Can be changed usually by the manufacturer using special equipment used for storing odometer reading and an electronic dash display. Yeah, so no memory here now. So for instance, you change the clock. And you want to keep your original odometer reading. You have devices out there where you can use to actually alter the odometer reading so it can match your reading that you actually have, because some odometer reading is stored on the ECM itself. So even if you change the clock and the clock has say one thing, you can go actually go into the computer itself with some vehicle and see the original mileage of the vehicle have, so you can actually match it back to the clock. Burn plastic. Sure. And now we have the electrically erasable programmable read-only memory. Can be altered by the technician in the field. Allows the manufacturer to change operating parameters if a performance or drivability problem is discovered. Yeah, so like for this now, it can be like, for example, a Mazda CX-5, sometime the transmission itself will actually start change erratic. So we'll actually have to like update the transmission itself to a later software. And then after that now we have like proper driving drivability out of the vehicle. So sometimes components on the vehicle itself need to be updated, especially with these more modern vehicle. Yeah, and we actually like have like set of vehicle coming in with name Bake or Beijing. Once them come out here, we normally have to upgrade like the fan software to match our climate condition. So that is a example of that. So we can like alter stuff or update them to get the best performance out of them. All right, so we have other memories here like the flash erasable programmable read-only memory. And that is similar to the EE prompts in all respect. Keep alive memory. So memory chip that allows the computer to have an adaptive strategy, stores calibration information that enhance vehicle operation as parts wear. We're supposed to familiar with that, with like especially the German vehicle and like the battery. So for instance, the battery deteriorates, so it now keep the charge. What the computer got to know, I gonna make the alternator compensate for the battery shortage. So if the battery did for like a supply at 12 volts or 13 volts, and the battery start deteriorate and I'm gonna supply 11 volts, the computer now will actually command the alternator for supply that additional volt, or to use the DC to DC converter to assist with that. So once you replace the battery now, you have to actually reprogram back that new battery to the vehicle. So the computer now will stop compensate for the shortage of the older battery. So if you don't do that, the computer going up compensate, and then you put a new battery in there, and then you probably burn up something. Right? So it's like you recalibrate the system. So that's how the computer works. The computer will actually try and, as them say, keep alive memory. So the computer objective is to keep the vehicle running at optimal performance at all time. All right. We have output drivers, control current flow through the actuators when energized by the computer. Drivers ground the actuator circuit, providing actuator operation. Processor memory bus, a pathway by which sections of a computer communicates. Microprocessor controls this flow of data. So writes data about vehicle operation into memory, and read data about how the vehicle should operate from memory. So as I say, it always have a reference. So if it get information from sensors, and based on them information, the way it gonna say, well, this is not how the vehicle should be operating. So it either gonna trigger the light and say, well, something is wrong right here when it compared to memory. All right, multiple sensor inputs. So the computer system uses more than one input to make most control decision. Fuel injection example, or for example, engine coolant temperature sensor signals a coal engine. So so we have a cold start. Computer would use both speed and temperature signals to increase injector pulse width to enrich the mixture for coal engine operation. And this is a example of that. So we have low engine speed, we have our trigger wheel and low frequency going in. We have a computer and short low frequency voltage pulses. So we have very little in a short pulses. Say you have the fuel basically trickling from the injector right there, and the picture below, actually you see the frequency increase there with the cold start now, right? So And the temperature sensor is incorporated in this one. So engine temperature sensor call override speed sensor input. And then we have our even longer voltage pulses. And we have more fuel going in the cylinder for the cold start operation. Computer networks, series of computers that control different systems but work together to improve overall vehicle efficiency, shares wire, input signal and output signal. Computer exchange data from sensors to prevent duplication of parts and to reduce wiring. So what that actually means is multiplexing, or you can call it CAN communication lines. So you can have that as an example, like me now. Say for instance, I am a sensor right here talking to you guys. And instead of a call all of you individually on your phone, we just do a conference call. So me can communicate to all of you through one line. So would I have a reduce in the number of wires? So we'll have like lighter components. So one person speaking, everybody hearing. So same thing with the computer communicating with each other. But the thing with that though, so computer will actually need that information, we use it, while some will just make it pass because it not relate to them. So you have the information passing, who want it, take it. But the sensor speak to everybody. So who have use for it, I go use it. Like for instance, the speed sensor, the clock use it, and at the same time, your door actuator use it. So once again, well, with most modern vehicles, once you go in them and you drive off, the door automatically close because it have a computer where I get the reading from the speed sensor. And as well as the dashboard clock, I use that information as well. While other modules probably don't use it. It's not necessary to them, so them just make the information the pass. Now follow? Hello?
Yes, I'm following.
Oh. Yeah, man. So that's what I mean by computer network. All right, actuators, devices which allows a computer to do work and alter the operation of other components. Actuators may be found anywhere on the modern automobile. All right, so actuators would be like the computer send out boys. All right, do this, so me do that. So it actually command them to do work, right? And sensors now would be like messengers, in other words. So one is a messenger and one is a send out boy, in layman term. All right, actuator classification. So actuators can be grouped into the following categories. So it can be a solenoid, relay, servo motor, display device, and control modules. So actuator classification. So this is a picture showing an example of those. So we have our DC motor. And the thing with actuators, them always have a hot wire to them, meaning a positive. And the computer control the ground. So as I can see, the ground is coming from the computer itself, and the positive is connected directly to a power source. So our DC motor, our solenoid, our relay, right? And read out our display, solid state. So basically, them say a screen can be activated. So actuator operation, when the computer turns on an actuator, it normally provides the device with a ground circuit, as I was saying. Current can then operate the actuator. So actuator operation. So we have the microprocessor, provides control signals to the output driver. And the actuator to the right, as I can see, when it passes through the driver, there is no activation taking place because it is not energized. But the other two now, you can see where those are energized, right? And voltage apply. So the computer actually communicates with the actuator. No, the processor actually communicates with the actuators through drivers because so for instance, if when you apply a 12 volts to a light bulb, if no ground is present at one leg, the positive will go flow through the bulb and go through the rest of the circuit, right? So them do that for you don't have a 12 volt of flow into the computer itself and burning the microchip. So the driver, as I can see, is a diode. So that little sign, that triangle sign, it shows the direction in which the signal can pass, or is a valve in other words. The diode is a valve. You follow? So if the computer is not sending a ground, the positive will go flow through the actuator and back into the circuit. It will go stop right at the driver. It can't pass unless the driver is malfunctioning or have a malfunction. Then you will have the current flowing in the wrong direction and damaging the computer itself. Do you follow?
Yes,
I forgot what I'm on up in the car.
following.
Following man, mostly.
Yeah, man. Start asking a big question, you know. Getting active. All right, so solenoid operation. So computer grounds a solenoid circuit. Current flows through the solenoid winding. Magnetism move the plunger mounted in the solenoid winding. Plunger movement is used to operate a device. Fuel injector, vacuum valves, door locks, and so forth. And yeah, man. So in contrast with the sensors, the sensor actually capture moving energy, or change one type of energy to another form. So it will change moving energy or kinetic energy, heat energy into electrical energy, while actuators change electrical energy into moving energy, right? And anybody know which device can actually change electric energy into heat energy? Well, kind of go a little bit complicated based upon the context. But like for when you're familiar with glow plug, them use on diesel vehicle.
Right.
Yeah,
No.
so yeah. Alright, so glow plugs are like something where them use on diesel vehicle. Each cylinder have one, say if it's a 4-cylinder diesel engine, it will use 4 glow plugs. So we do it preheat the the combustion chamber. So it helps to bring it up to operating temperature quickly, so the vehicle can start easy. So like you have some diesel when the day I try to start it, it just the turn over, and it have to go through a whole heap of cycle before it actually start, and you would just say, well, one of the glow plug faulty or something like that. So yeah, so just like how you have temperature sensor where convert heat energy into electrical energy, glow plug actually convert electrical energy into heat energy. So we can just add that to the actuator list.
You have the truck engines to have the thermostats like are coming at kettles. When you plug it into a 110 volt, it heat the engine block, the coolant in the engine block.
Yeah. And we actually have oil heater or diesel heater or gas warmers. Yeah, so some of them can actually warm up the diesel too. So it in cold start, and especially for a person in a colder weather or climate. Yeah, so we now actually look upon what is here. We have whole heap of other examples out there if we think about it. So automatic door locks. So here we have the vehicle speed sensor inactive, meaning the vehicle is not moving, no speed signal going in, right? And door solenoid off, door unlock. So once it's not energized, the door them are gonna fly. Once you switch off the key with some vehicle. Once the vehicle is in motion now, vehicle speed sensor generate a signal, clock delays driver action, right? And that now gonna energize the actuator, boom, door close. All right, relay operation. So the computer grounds the relay coil winding. And as I must say, with actuators where they won't be really anything glow plug injectors, the positive always on it. You always have a 12 volt once you turn on the ignition. It is only controlled by a ground at all time. So the computer ground the relay coil. Ground the relay coil winding. Low current flows through the relay winding. Relay coil field will then pull the mechanical contact close, allowing high current to flow to the load. Anybody know what a relay is, or how you would define a relay?
A relay basically is a switch.
Yeah. Any other deep definition, like more in depth? It's simple, but more detail.
Yeah, relay is basically like a coil which operates off of magnetism. So once energized, it creates a magnetic force inside which then pulls down one side of the circuit to close the circuit, close or open the circuit, depending on which type of relay it is.
I have like 5-pin relays where normally open or normally close.
Normally open or normally close.
Yeah. So basically we can say a relay is an electromagnetic device that uses a small voltage to control a large volt, right? And the reason why would I use that definition is because, say for instance, the ignition bar, especially with button start vehicle. Button start vehicle uses like some 20 gauge wire, like very small wires. So just imagine those small wire running directly to the starter. As I press it, the circuit should have burn up. So what them do now, them just use small wire. So the low side of the relay would have control the higher voltage side. So instead of have the high voltage passing through the key barrel, you just use some fine wire to control the low voltage side of the relay. And then that now will allow large voltage to pass to the starter. So really you can look upon it as a protective device as well. But as I say, you can take note of that. So a relay is an electromagnetic switch that uses a small current to control a larger current or voltage.
Sure.
Yeah.
Agreed.
Yeah, man. Or a small load to control a high load or a large load. All right, so relay operation. Computer ground. Yeah, so once the computer is ground, the relay is energized. That magnetic field actually closes the switch and then current flows from the battery to that fan or motor or whatever that is right there. And yeah, so the top diagram, that is when it is not energized, and the diagram below shows when it is being energized. So high current load actually operates the fan.
Yeah, hello?
Yeah, I'm hearing you.
Yeah, what I just reached home, so I switched now to my home Wi-Fi. Sorry about that.
Oh.
A transformer could be considered a relay too.
Transformer.
I just trying to think.
No.
No, I'm going to say that because the computer wouldn't actually command the transformer for do anything. The transformer is actually doing its own duty.
Okay, that's what you mean. Yeah.
Yes, so its duty is to either step up or step down voltage. Yes, so
and it we constantly.
Yeah, but at the same time, it's an integral part of the computer at the same time because the computer now going to deal with high voltage, so we are always have to have a transformer for actually step down the voltage for the computer or convert it from AC to DC. So it still works, but I wouldn't consider it an actuator.
Yeah, okay. Understood.
Yeah, man. All right, so the servo motor is our next one. So servo motor operation, computer can ground the motor circuit and so much time, I'm telling you that. So at no time, you should say the computer control the 12 volt, it's the ground. So every device, every unit we move to, them so the computer control the ground, right? So the computer can ground the motor circuit, turning the motor on or off, or reversing motor rotation as needed. All right, so stepper motors use separate winding to cause rotation in both directions. Reversible DC motor use just one winding. Computer can reverse polarity and the winding to change armature direction. All right. So
what's a stepper motor? Sorry.
Say that again.
A stepper motor. What's that? I heard the term before.
Oh, so a stepper motor can actually for example the chuckle body. So instead of just make one rotation, it can actually rotate and stop in particular position. So it can go back and forth. So when you look at the gas pedal, it actually go in the reverse direction. And as you step on the gas, it goes in the other direction.
Sorry, light went a while ago, so I didn't hear your explanation.
Yeah. So may say with those motor, you actually can,
Mm-hmm.
all right, you know, like a regular motor, once you put current on it, it just spin. And if you take the current off it spin until it stops.
Hold on. Right, it's slow. Yeah, it's gradually slow down and stop. Yeah.
Yeah. With a stepper motor, the computer can actually control the position of that motor. So the computer can make it turn halfway or turn right round
Oh,
and
right,
go there. Yeah,
right,
so that's why I
right.
say, like, for example, with the throttle body, when
Mm-hmm.
you step on the gas pedal, the computer commands the motor to move in certain position, be in
Right,
relation to your foot position and the gas pedal. And if you show the release but the gas pedal, it will go back in the opposite direction. So a
right,
stepper motor basically can actually move in steps then.
right. That's what you mean. Yeah.
Yeah. And them tell you the different types of them have. So
Mm-hmm.
the reversible type stepper motor would be like your door motor in the vehicle. It can have two wire go into it, but the polarity can change by the control unit.
Mm-hmm.
Right? So and as I can see, you can move up the window and stop at the desired position where you want. While if you should use a regular motor, when you release the current, it will go on show up the glass until it run out of momentum.
Mm-hmm.
Yeah.
Right.
So man, if that explanation is clear enough.
Yeah, man, that's good. Yeah, man, that's excellent.
Oh, all right. All right, so this is an example of a stepper motor or servo motor operation. So the specific coil can be energized to attract and stop the armature. Right, so as I can see, the computer energize a specific coil. So it come like a brakes. So it holds it in that position. As I can see, the lines in blue,
Mm-hmm.
the coil that is energized in the blue actually hold it in that position. And as I can see, you have two other coils in black that is in the off position, right? So specific coils can be energized to attract and stop the armature,
Mm-hmm.
right? So specific actuators, common actuators used on modern vehicle include fuel injectors, solenoid valves that control fuel flow, fuel pump, electric motor driven pump. So as I can see, components are endless. So anything where you can classify it as an actuator is anything that the computer can actually tell to do work, right? So you know, once you turn on the ignition, the computer actually tell the pump for prime. So you're gonna hear the pump prime and stop. Once you turn on the ignition, the computer will command it to spin constantly. If it's a case where you're stepping on the gas pedal, like you floor it, or you increase the RPM, the computer can actually tell the pump to spin faster. So it can supply more fuel because more fuel is needed in the rail, right? Like for turbocharged vehicle, probably upon like lower boost settings. Where we're going. Upon a lower boost settings, the computer will command the pump to spin at a certain RPM or at a certain speed. And as boost is increasing, you know, fuel have to increase with that. So the pump will actually have to spin faster. So that can be computer controlled and classified as an actuator. Something simple as a fuel pump. All right. Still on specific actuators. So idle air solenoid, right? And that can be like an idle up valve, like when you turn on the AC, actually the valve actually compensate for the added load. So the vehicle not stall when you turn on the AC, whereas if you're at closed throttle or no throttle position. While you have some vehicles don't use an idle up solenoid, the actual throttle the throttle body itself, the electronic control one, the computer can just change the position at the butterfly to compensate for the AC where you just turn on, while some just use an idle up solenoid. Right, and that control airflow into the engine to control idle speed motor, reversible DC motor that opens and closes the throttle valve to control idle speed. Right, EGR solenoid open and closes small ports to control exhaust gas flow back into the engine. Right. Now we have our canister purge solenoid. So control flow of fuel vapor from the fuel tank into the engine for burning, and that during cruise. When you cruise that it trigger that though. So probably up to 2,500 RPM and below. All right, and door lock motors, solenoid that move latch mechanism to lock and unlock the doors, electric seat motor, reversible DC motors that move the seat into the desired position. And same thing with it, as I can see, once you stop, press the button, the seat stops same time, it run off the same way. So yeah, get a full understanding of the stepper motor.
Yeah. Can I ask
Yeah.
something?
Yeah. Yeah, man.
The canister, you kind of lost me back with the canister though.
Oh, the first canister.
Yeah, it kind of lit me because
Oh, you
I need
want
some
to know what
explanation.
it is? You want to know
Well,
what
I
it
know
is?
the gas is I know the gas is in the gas tank, and I really don't know how the gas actually reach to the pistons to do what it do and what. But you're saying that this canister only work at certain speed or something. I don't understand. You know,
Oh.
the full process. In normal operation, what happened to the flow of fuel vapors from the fuel tank into the engine for burning?
All right. So all right. So I'm gonna split it so you can understand it. So you see the fuel system. It would consist of the fuel pump, the line, the rails, and the injector them, right? So through all of those components, that are how the fuel actually reach to the engine itself for burning. But how the purge canister come in play now? You ever throw gas in a buckle and cork it? Anybody?
Yes.
Yeah, man. So to the buckle, it swell, right? The buckle not swell.
Yeah, man, the buckle is still up.
Yeah, pressure build up in the buckle.
Right.
Yeah, so what the purge canister do now, especially when if you should shake the buckle, the pressure will even get greater in the buckle, right? So what the purge canister do, while you drive, instead of when you go through the bumps and deeper craters for them with on the road, pressure go end up a build up in the gas tank. So this excess pressure actually your gas cap, that are the cap where you pull for pouring a gas, it actually spring loaded. So if your purge system not work, it actually gonna lift the valve on that cap and it gonna bleed off through there. So the pressure have to go somewhere. So what the canister do now, it relieves the tank of that pressure, but instead of vent it out in the atmosphere, it send it in the intake. In the intake, right? You following? Hello?
Yes. Follow.
Yeah, man. So it just there for regulate the pressure at the fuel tank, right? But it don't go do that
Yeah, I pick up what you're saying.
during cruising operation. While cruising, it don't do it when you have full tilt.
Oh.
All right, and that's why, like for instance, when you got on a gas pump, when you go on a gas pump and the pump fly, and the pump attendant asks me if you know want to tap it up, it's not a wise thing. Once it fly, make it stay the way it is, because the tank actually need that space for the purge system to work. Okay, see if you constantly full it till it come all the way out to the filler cap, what go happen is you will find the fuel will end up actually enter the purge system. And fuel not enter it, just vapor. So if you always seal the tank, you're not gonna leave no space for vapor. And then fuel can actually enter through that and enter the intake manifold, and because you have gas as a rush off in the engine now, where you have now hydrolock. We have a hydrolock of the piston. So we know say liquid can't be compressed. So
Yeah.
trying to get additional gas can actually cost your engine. Right?
Oh.
Yeah, so you can flood the engine and hydrolock it
You
and
know,
main rod. So it good for leave when
it's something very serious that he does mention, you know.
yeah, man. We'll probably take it for granted at
Because
times.
I see it in the gas stations. I see it in the gas station regularly. I see where they pump in the gas, and the man will shake the vehicle for thinking that more gas will go in.
Yeah, man. My pocket, like sun.
Yeah, but yeah, him think of some my pocket. But it's very serious. That is very, very serious. But anyway,
Yeah, man.
very, very serious. It sounds simple, but it's a very serious thing.
Yeah, serious, man. When it fly, make it stay right there. But then again, it just boil down. If you know, you know. If you don't know, you don't know. So who know now gonna do it?
But I didn't mean to cut you. But you know what? But no, it's something that everybody should know. It's not even something that is optional. Because even the pump attendant should know about it when the person. But well, I guess the gas station want to make money too, eh? So
yeah, man. Some more gas to get in.
we live in our world.
Yeah.
Yeah.
Yeah, man. Trying to get these products out. All right.
Yeah, what it could kill somebody doing it. Anyway, yeah.
Yeah, man. So next component is the ignition coil. Changes low voltage into high voltage that operates the spark plug. So the person who did ask about the transformer, well, probably see your answer here. You can look on the ignition coil as a transformer, stepped up transformer, basically. So that would answer your question for that person.
Yeah,
yeah. In the form of an ignition coil. Yeah. So ignition, yes. So the ignition module uses computer circuits that controls the operation of the ignition coil, right? And as I always say, we're controlled by a ground. We always have a 12-volt live on the coil wire, right? As soon as that ground is missing, that 12-volt collapse into the secondary circuits, inducing a large voltage to the spark plugs.
So hold on. The ignition module is a computer itself that control the ignition coil.
Yeah, and it cannot get feed reading from like the crank position sensor, cam sensor, and those stuff.
Right.
Yeah.
Okay.
As I was saying, the computer now go actually in dialect directly with the coil because as I said, the coil actually have or the actuator normally have a 12-volt live on it at all time once the ignition is on. So the module
Right.
actually or the module of the driver actually be a barrier to prevent that current from flowing into the computer processor itself and damaging it. You know, the computer normally just run off of 5 volts, but it have other stuff where step up the voltage you need to send it out back. But the processor itself don't deal with high voltage. So the computer got talk to the module or the driver, and then the driver say fire, and then the coil fire. Right?
Mm-hmm.
Mm-hmm.
But I kind of confused though, a little bit, because the ignition coil, I understand it being an actuator.
Yeah.
I don't understand how the ignition module is considered an actuator in this case.
All right. Let me see if we can specific that. Fire, may I forgot about now, you know. Let me see. You are the person where your Wi-Fi switch over.
I don't know if it's something I missed. Yeah, yeah. Oh, so you can explain it and I didn't pick it up.
All right, see it here.
Yeah.
As I can see, the driver, the output driver, or I can say module, right? The computer talk directly to the module. So it command it. As I always said, the computer actuator is anything that the computer tell to do something. So it's a send out boy, right?
Mm.
So it tell the driver or the control module, say, yo, tell the coil to fire. So it command it to do that work, and he have to carry out that due to the computer tell him. So it's an actuator. So once me can command you to do something, you're a slave to me then. So actuator is a slave. So look on it that way. But why does it use the driver or a module? As you can see, those triangle things that you see in the driver, they are diodes. And what we know about diodes, current can flow in one direction through a diode, right?
One direction. Right, I understand.
So because the actuator always have a 12-volt present when you turn on the ignition, if you never have a diode, which part of 12-volt would that go? Right in the computer, right? Because once you have a coil of wire and it should operate on a negative and a positive. If you put positive alone on it, the positive will go flow through the coil and go right through the circuit and go right up to the computer. So the driver would be a barrier now with the diode. So the current now go flow through the driver and then go to the processor and damage it. So the computer, so it's just like you're gonna look on like drug kingpin. Nobody not talk to the boss, but him always have a middleman. Especially if I watch Mafia show. Them have them young man, them will do the work, and then you have a next person in dialect with them, so some of them don't even know them boss. So all these actors know is that somebody tell them to do something, but them don't know who command that person. So you can look on it from a real life scenario. So that's how the driver, the module come in place. And that's why we say we have can communication where modules communicate with modules. Networking. Which part am I reach now?
Okay.
Yeah, man.
You didn't reach. Yeah, right there, so.
Just want to make sure I'm not leaving nobody behind. And the rest of you guys don't have to talk, you know, if you don't understand something. Because you see this young man in my talk, I want to know what I'm going.
No problem.
Yeah, understand most of our artists are forest too.
Yeah, man.
Yeah.
Yeah, well, let me see where the end of the slide is. Oh, so I think at the end of the slide here, this. So give me a second, I'm gonna switch over to the other chapter. Everybody seeing that?
Yes.
Oh, all right. I go on good then.
Yeah.
All right, so it's a chapter 18, and this have to do with onboard diagnostics and scan tools. So the contents onboard diagnostic system, scanning computer problems, and energizing OBD1 system without a scan tool, erasing trouble codes. You know, we kind of step away from OBD1 system, actually, and modern most every vehicle from 2000 onward use OBD2 system. All right. So onboard diagnostic system, modern automotive computer system are designed to detect problems and indicate where they might be located. This has greatly simplified the troubleshooting of complex automotive systems. All right. So OBD1 system. So that are pretty much any system from 99 backwards. So below 2000 we have OBD1 systems. So most early onboard diagnostic system could only check a limited number of items. Diagnostics were often unable to isolate problems within a circuit. There was little standardization. Each manufacturer used different connectors, terminology, and trouble code identification. So back then, the system, the technology and the system was difficult to deal with. So for instance, one manufacturer, so for instance, P0301 code as a cylinder one misfire code. And so for instance, Nissan used that as their trouble code. And next manufacturer use that same code and put it as at a different problem. So that person probably say, this is our injector code. While one person say, all right, this is our coil code. So you need to actually have database specific for the vehicle where you work on. And everybody used to use them own diagnostic ports. So instead of you have one scan tool, you can scan all vehicle, you have to have adapters. So the thing never standardized at the time. So when you buy a scan tool, it will come with these whole barrage of connectors to adapt to the various type of vehicle where you're gonna use it on. All right. So OBD2 system designed to more efficiently monitor the condition of hardware and software that affects emission. And we don't know, say everything what them do nowadays. Every computer we develop with these modern vehicles, emission of them concern. All right, so diagnostics can detect part deterioration, not just complete failure, right? So especially with stop-start vehicle. Because the starter go actually use more than a regular vehicle that don't have a stop-start system. And when we say stop-start system, are those feature that, like, if you slow down or stop in the traffic, the vehicle automatically switch off. And if you like unbuckle the seatbelt or turn the steering or lift your foot off the brake pedal, it start back and then you proceed. So that do prevent you from burning unwanted fuel while they're idling and saving, I guess, at the same time. So because those type of starter normally have to go through more start cycles, the computer actually monitor it. And probably after a certain amount of count, it can show a code and say you need to service a starter. And it will tell you that before the starter actually break down. It now go wait till one day switch off in the traffic and say, you know, I'm not start back to the door. Yes, so it actually can give you a heads up, so right, it's soon time for replace the starter or get it service. All right. So this is how technology actually improve. All right, OBD2 standardized data link, connectors, trouble code, terminology, and the scan tool capabilities. Right, so as we said earlier, you used to have many connectors. Nissan have them own type of diagnostic port, Toyota, Benz, BMW, but now them standardize it, so everybody have used the OBD2 connector. So once you have a machine, once the vehicle is above 2,000, you can just go and plug it in it. And this tool should be able to communicate with it. One time you'd have to buy like specific tool for work from BMW and Benz, but now, as I always say, standardized, so everybody have to comply. Just like how iPhone have to start comply with Samsung.
Yeah, it's standardized.
Charger wise, yeah, they must standardize the charger. So everybody are gonna use a Type-C charger. Some know Apple fans kind of sad about that, but welcome to the Samsung world.
Sir, you have to something.
Yeah.
You kind of standardized still, but you have some of the vehicles where you still have to purchase like certain things to you, just still have to purchase for certain software and still use it. But the standardized that you could just pull the code. But when it come down to the rougher side, right, you have to have the software to either get into the ECU or something like that.
As a the protocol for some of them different.
Yeah.
Okay.
Yeah.
So
So the protocol are got different, and then it boils down to how tall your pocket is. Because you still have scan tool we can do everything. Like you have the top down, you have the scan but them type of scan tool you talk about like some 2,000 US per month just to keep them alive. If you stop pay that, this tool just go blank. But them tool you have to charge your money when you have them type of tool. But the look of common tool we get for 100 and 200,000, them are gonna have them limitation where under the dealer go have them privilege there. But if you're willing, if you pay for the high caliber tool them, your subscription fee are high. So
As you know, somebody who have one of the launch like mine, but it coming like mine more upgraded than him. Every time,
yeah, so that may I say I got different caliber.
yeah, every time I want to reprogram a hybrid transmission, I
Yeah,
have to use my own data.
yeah. Them man. So some have more, some is of a higher caliber than some. But the main objective is them have to have the OBD2 connector and certain basic stuff them have to comply with. And the information display like the codes have to comply with certain standards. So as I say, if number one mean injector, right across the board with all of the manufacturer them one of the mean injector, while back then it is different. So certain things standardized to make the thing more simpler to deal with. All right. So systems monitored by onboard diagnostics. So these are just example. In the middle, we have the computer, and these are the various inputs where I go to the computer at once. That's why earlier with this, we actually have a buffer in the system for actually deal with all these information coming in at a rapid pace. All right. So as I can see, we have, well, we can just look on the screen because this is a lot to go through. So the ones in blue, those are the older OBD1, and the ones in yellow, OBD2, right? And as I can see with the OBD2, we have more fancier stuff, like output shaft speed. So with the OBD2, you can actually monitor shaft speed, whether that one be drive shaft, and many other fancy stuff versus the OBD1 system.
Can I ask a question?
Yeah.
Yeah. So the OBD2 does cover the both blue and yellow now?
Yeah.
Or is it that it don't?
It cover both
Okay, I just want to make
blue
sure.
and yellow. Yeah, cover both of them.
Right.
Yeah.
Okay, I just want to make sure that it never mean that you stop monitor the blue ones now and you're going to monitor the yellow ones alone.
Yeah, man. Yeah, you're still there. So I'm gonna shift this one.
Okay.
All right, so a malfunction indicator lamp, the mill or the check engine light, more popularly known as. If an unusual condition or electrical value occurs, the computer will illuminate the amber color indicator on the instrument panel. This will notify the driver that the vehicle needs service. The technician can then use a scan tool to retrieve information. Continuous illumination means the trouble should be repaired. So once the light stays solid, it not go nowhere. That means repair is needed. A flashing mill or check light means the trouble code. The trouble could damage the expensive catalytic converter. So once the light flash, it means the catalyst is at risk. So that could mean that you're having a misfire. With my Nissan, once the check engine light start flash, I know some burn a coil. Right? I'm gonna start dump gas, and once I start dump gas in the cat, you can clog it up. So the light can actually give you an idea of what's happening. So once you have a flashing light, you know, say you have an emission problem, meaning it can be a fuel injector or just say a misfire on a holding. Once you have a misfire, the mill light will flash, but not with all vehicles though. All right, so intermittent mill means the problem is also intermittent. So today the light there, man, after a few cycles, the light going. So back and forth, and trust me, one of the worst problems them there to try and catch. I don't know if you fix it, and you don't know if it'll come back until it come back. So one of the hardest problems I'm have to deal with. The one with the solid light on.
But can I ask a question?
Yeah. Yeah,
But
go
I
ahead.
ask it with all the circuits in the system, with all the circuits in the system and all those computer and monitoring and sending activator and activating this and that. Why would an intermittent light be such a problem? Just a brief example why it would be such a problem with all the kind of controls in the computer that send the signal to open this and close that and all them things there.
Yeah. All right. With that now, everything have its limitation, right? And the thing is with the computer can constantly monitors sensors, right? So for instance, the sensor is faulty, or the sensor should say no, do it no work today, lazy today. The computer go say, all right, here, the computer go trigger the light, So the thing is with the intermittent problem, some of the time the customer is not near a mechanic at the time or near their mechanic to actually put the tool on it. And by the time they reach the mechanic, it gone, right? So the reason why it go away, because the computer, even though the component is faulty, the computer will still monitor it. So tomorrow now it wake up and say, right, I gotta do some work today. And the computer watch it show a few cycles and say, oh, it look like it might work, man. Maybe it was just a glitch, boom, me take off by the light. And then shortly after, my boy say, right, when I do the more work, I done for the day. Computer go watch him and then show up back the light again. And by then the customer probably a couple kilometers well from here, the next side of the island. I have some customer, if I not feel them mechanical touch the car, it now go look one.
Me know.
Yeah.
Same here.
So,
yeah.
But
it leads to a further question though.
Yeah.
It leads to a further question though. Why that intermittent behavior, like it do it and stop and do it and stop, is not stored and a protocol set up for the tool to pick up, said, oh, so it do it there so and do it there so, and it store that information. I don't know if you pick up what I'm saying.
Oh yeah, man.
This errant behavior of that sense.
All right, you have all right, some of the time, like if vehicle come and them say they might have such and such problem and the light they there and it go away. Some of the time the code is still there, but it is in history. So like, I know like sometimes when you use your scan tool, you will see a code mark current or permanent, and then you have a next code that store as temporary or history. So the history code now, sometimes the history code don't trigger the light, but the computer itself, as I would say, it would have stored it in a which memory, the RAM. But once you disconnect the battery, that it loses the memory, right? So some of the time, some computer as a vehicle varies across the board, and some vehicle computer have more luxury than some. Some vehicle actually can store them VIN number, while some vehicle don't do that. So some vehicle computer actually store those code as history, and it go better for you as a technician, while some of them is like it don't have a ROM memory. So with that one now you have to go up on a wild goose chase. And then the reason I say the intermittent problem can be a problem is because if you suspect, say, right, may I go execute such and such thing, and that should fix the problem because it is intermittent. You don't know if the problem really fixed. She can drive back and say, so the light come up back door. And you say, all right, I have to go take a next look at it, and then you have to take a next step again. Because if it's an expensive component, you're not really want to jump and say, you buy this. You're going to want to make sure yourself, so probably you're going to shift around certain things and see if the problem shift. And if it shift now, and you see a code come back and you shift in the position where you set it, you're going to say, all right, you are the culprit. So you would have to do some R&D or some troubleshooting to make sure with those problems. But the one with the solid mill light, once the problem fixed, the light will go away. If the problem not fixed, as I delete the code, it pop up back. Right? So as I'm saying, the intermittent one, they're more difficult to deal with. Especially if it's a expensive component or show up itself. Or someone pull the trigger upon that. You have to have data to back it up. Unless you can actually physically test it and then it's all right. It have a breakdown. Follow?
Yeah, man, I pick up what you're saying.
Yeah, man.
Follow.
Somebody saying something?
No, just confirm that we're following.
Oh, all right, cool. All right, so diagnostic trouble codes, digital signal produced and stored by the computer when an operation parameter is exceeded. So as I say, is either a man decides say I'm lazy today, or I'm just planning to do more work than we really are going. So I'm say, you know, so I sweep up the whole place and when you come, I just the doorway sweep up. Yeah, so but when I'm just say this not match up, so I'm exceed what I'm claim say I'm do. Or am I underwork? So is it them overwork or am I underwork? And master say I want it to be done this particular way. So you might throw the light and say, yo, get rid of him. All right, so the parameters include sensor voltage range, actuator current flow, and actuator movement. All right. And I want to tell you, so the sensor can actually, hear me, the computer can actually have a sensor that is monitoring the actuator movement as well. So it can know the position of the actuator to know if it do what it actually tell it to do. So if the computer say this amount of movement, especially like with the EGR valve, when it make exhaust flow back into the intake, the computer can command how much flow it want, and at the same time, on the motor actually have a position sensor in it to tell the computer what position the EGR valve is at. So based on that position, the computer knows, say, all right, this amount of exhaust of flow then. So if the actuator can think, say, I go there down there and just tell the computer, say, yeah, man, me I go on the record, supervisor down there with him, man. So yeah, you follow? Yeah, man. So a supervisor watch him. So certain people get supervised while the computer will just leave certain people for just do what they want, the way him can't trust. So a man them him can't trust, it makes
Depends on how
somebody.
sensitive it is.
Yes, so the person who is sensitive are the man who him can't trust. So him have somebody a monitor him.
Yeah.
Yeah, man.
And I sense that like for the door locks, him don't have nobody watching the door lock. For them saying it lock that
Yeah.
doors, but those that have variable movements.
Yeah.
Like you said, that are
Yeah.
variable movements.
Yeah, you need to know them.
Constant movement based on speed and temperature.
Yeah.
You must have a soup down there.
Yeah, man. I watch them. So computer system problems. So if we have so with this now, we have a broken vacuum line. So that I go actually a sensor, we have a sensor failure. So the sensor must be failing. So where this basically I tell you say, if something mechanical is happening, like a mechanical failure, the computer must detect the mechanical failure, but it go blame the person who do the monitoring. So it can say, you know, so the airflow sensor is faulty. Really and truly, not the airflow sensor, but because the oxygen sensor probably get more oxygen than where the airflow sensor is actually saying is coming in. When nobody not at fault, you know, but somebody will get beaten feet. But when really and truly is a vacuum leak we have, right? Or it can be a loose connection. So a loose electrical connection, disconnected wires, right? A broken wire. Computer itself can malfunction, but you know what the problem with a computer? It never tell on itself. That's the worst part about a computer. It now go tell upon itself. Right? So you would have to know.
Just like how Just like how management never usually blame itself. Blame themselves.
Look somebody for show under the bus. Yeah, man. Yeah.
This is similar to the fact that if you have an O2 sensor signal coming up, it could be that the catalytic converter block. There's nothing wrong with the O2 sensor. It's just sensing that down the line there's a package.
Yeah. But what it now got able to detect the alright. So you would actually what them actually do now with modern vehicle, especially diesel, them put a differential pressure sensor on the system. So if you look for most DPF system on a diesel engine, the catalytic converter have a whole heap of sensor going on it. It have EGT, which is exhaust temperature sensor. It have the differential pressure sensor. And what the differential pressure sensor does now, it monitor the pressure at the front of the catalyst and the pressure behind it. So if it knows, say it targets such and such PSI at the front and all of a sudden it starts spike and a stay spike, you have the DPF light start flash. That is a particular filter and short. So you know, say the catalyst are either want to replace or clean. And where most manufacturers do to overcome the blockage of that, them start, we call it the diesel fuel, the exhaust fluid. So like with some Nissan Navara, you're gonna see two gas lid. One of them is actually for the diesel, for the exhaust fluid. So it helps with cleaning the DPF system or the catalyst, in other words. Right? And some of them will have one gas lid, but when you open it, you actually see two filler neck. Yeah, so
The Isuzu trucks.
Yeah, so as I was saying, with the emission thing, more and more vehicles are actually come out with these type of stuff.
What the Isuzu normally do is force it to regenerate.
Oh, yeah, and yeah.
So if when it forces it to regenerate and it's still not thing that it bring up the mill, and you have to use the scan tool now for manually
do it,
manually clean the DPF.
Yeah, and some of the time it is that bad that you actually have to remove it and soak it in the solvent to break it down.
But
like with the Toyota IS them, some of the time we run the rejuve on them and pay 2-3 times and the van still not in the power. We have to take it off and actually submerge it in the fluid with themselves to do that particular stuff.
But can I say something though? You were saying that they're doing more things to improve on this, but the fact that vehicles are going electric, because most of the problem is from a gas operated vehicle.
Yeah, but
so going electric.
But you know, say going electric is just shifting pollution from one end to other.
No, man, I agree with you on that point. But in terms of these little figures and what they call it, the OBD thing on the dashboard showing up, mill light and all those things.
Yeah.
It's really simple. The fact that you're using a gas vehicle, because some of those problems, can you say 80% come from fuel?
Yeah.
Well, emissions would, as you say, would be come from electric still, but not from the vehicle itself, maybe otherwise, and engine problems. But the fuel system is really, most of the computer problem come from you having to work a fuel system vehicle.
Which we can well, these technology actually work, you know, cause you remember like probably 10 or 15 years ago when a van, we're not even gonna say a truck, when a van passed the whole avenue block up. You can smell say a diesel truck just drive. Yeah. And if you notice with even modern vehicle, Anybody can tell me when last time see a modern vehicle a fume smoke through the tailpipe?
No, sir.
So you see the thing with modern vehicle now, you see if you have a valve seal problem or you have piston ring problem, you're not gonna know. Because the catalyst system is working so good that by the time the oil for pass through and burn and it reach your tailpipe, a clear smoke will come through. One time you put a score on your tailpipe and go look and say, oh, you want rings, man. You now pick up that again. That will show you how far them come. So them actually work, but it's just that it take money for work. So the cost of things will go up.
Right.
The cost of stuff will go up, but it actually work.
But
So,
you mentioned the point that you say you're gonna need rings. But because it works so good, it might not shut down for you because you need rings and the system not to say you need rings.
yeah, and then I just you have to go know so you lose power then.
Yeah.
You probably have to normally where your car, you could have just step out and circle at one man and you find so your car and leave up to them something now it now climb it like how it used to. Right? Or you can find so you end up a misfire due to low compression and you just run a compression test and or anything like that. And I want to tell you funnily, these modern vehicles nowadays so they make for burn oil. Yeah, because they might use a technology called low tension ring to reduce friction in the cylinder against the cylinder wall. So you know, like first time piston ring them did a squeeze like against the wall, and a tight squeeze the way it use a squeeze against the wall would create friction or a certain amount of drag.
That's the word, yeah.
Yeah, so the low tension rings them now, them fit, them not create that much tension against the walls. So what them use with those engine now are a low grade oil. So like some 020 and some 5W20. So if you notice that the grade low. So that now going to help you slip past the ring to help reduce friction. So if you use thick oil, the wall and the ring them are go wear down fast. That's why the step wagon them, most of them you would have to dash them because them would have rings problem because people just throw the 1013 of them. When are some 020 and some low grade oil due to the piston, the engine construction. Right? But at the same time, they make for burn oil, but you're not seeing a smoke through the tailpipe. Right? So them work, but you just that it take money to replace one of them catalyst converter. Like for example, the people who live overseas, them a feel it if you notice the man, them a cut them off 5 people in car. Literally. Also see a few videos with those.
Yeah.
Cut off the cat them. Yes. Scanning computer problems. A scan tool is an electronic test instrument used to retrieve trouble code from the computer's memory and displays the codes as numbers and words. Many vehicles also allow the scan tool to display input and output operating values. So in other words, I can do live data in. So you can go live data and actually see what and one other good thing where you can do if you own a scan tool, like you get a vehicle, you know, operate properly, plug on your scan tool, see what the values, the various sensors and actuator values are when it is cold, when it cold start, see what them switch to when the vehicle warm up. See what happens when you apply a load to them and you keep that as your personal data. So you see if that vehicle or a next vehicle should come in the shop, you can say, all right, normally when the car pull, you should supposed to get such and such reading and right here, so it show this. I can't remember I get 6.5 for work on. I have the vehicle for about 2 weeks. Once I go in the vehicle, put it in a drive, the vehicle misfire as a diesel. If I disconnect the EGR system, the vehicle stop misfire. So in other words, once I create a vacuum leak in the system, the car drive fine. Once I close off but the vacuum leak, the vehicle misfire once I go in a drive. They are bounce through with it. The whole power and the trial and error. Until I start watching data values. Because you cannot watch data values, but at the same time, you have to know which data value fair watch based on the issue where you face. So I say, all right, when the car idle it, all right, I want to put it in a drive, the vehicle misfire. So I go so boom, I put it on the map sensor, I put it on the mass airflow sensor, I should say, and some other little sensors around it. When the car idle, it idle at the 4 grams per second, when I know it should be idling at as a diesel. So like with some regular vehicle, most vehicles can idle between 2 grams to 7 grams idling. When you turn on the AC, it probably go up by 2 or 3 more grams to that just by idling. So the vehicle idle at the diesel vehicle idle at 4 to 5 grams. I say that look normal. When we put it in a drive, it go up to 52 grams. So, oh, so the airflow sensor now, I tell the computer say the chuckle partially open, which means it open halfway. So where the computer started now a dump gas. So you know, so once you move off it, now get that amount of air the way the airflow sensor say it get, and the gas was a dump. So you can't burn it off in time, so you carry a misfire. So I'm saying, right, you are the problem. I have a attenzer on diesel. I'm going to be a diesel attenzer as well. Take out feed airflow sensor showing it, put it in a D, the grams go up to about 6 grams. I say, yeah, man, that's how you should be working. Just go buy an airflow sensor. So you see, if me never have the knowledge of how it's supposed to be reading under certain condition, but that's still a probably a vehicle that's still there. And we are talking from last year that. So some of the time, it's good when we know the values them. And I know something we are just going to learn overnight. And something we are going to learn overnight, but it's good for us take up the scan tool and go play with the car. And get familiar with stuff. Try to help. We're not going to know when it's going to help. Just by playing around. Yeah. Come on, so this one scan tool. Remember, it's a show. So on many vehicles, the scan tool is the only way to access an onboard diagnostic. And they may look like some older version scan tool kit. So this is how all a scan tool used to look like. It come with the main harness, and then the others them would adapt to it through the various manufacturers. So read the tool operating instructions, operating procedures varies. Yeah. So scan tool program cartridge. Kind of. Yeah, so something.
Yeah, can I ask about scan tools? Is there one you can recommend that does 12 volt and 24 volts?
All right, most of them can do it, but just when you buy the scan tool, you're looking at the description. Because you may have a RTL one can work on 12 volt while you have a next one that can work on both. So once you go buy a scan tool, you're looking at the description and it's going to tell you the system that can work on 12 and 24 volts. Right? So, which may expect if you're looking at the description for any tool where you go buy, because you go on with all of the modules them where it can check. But you know, want buy one and buy next month, you have to look for buy a next one.
Sorry, I lost signal a while ago. I didn't hear a thing you said after I asked the question.
Oh, no, may I say, well, with any scan tool where you go buy, I can't tell you buy a RTL, but at the same time, you have RTL work with 12 volt only, and you have some that can work with both. So may I say, once you go purchase a scan tool, you're looking at the description and see,
Okay.
yeah, which system it can work with. And Mark, I always recommend for you if you're looking at the description, because you go on know what and what component it can check. Because I'm saying, buy a tool today and next week or next month, you have to look for buy a next one, because you find out say you can't do what you want. All because somebody tell you to buy it. So you have to do your research for yourself with that.
Okay.
And do your comparisons with other tools. So if you choose to buy one, you just compare it with others and say, all right, based on the majority or the reviews, I feel comfortable choosing this one. Yeah, and
Okay, no problem.
yeah, man. So available system for systems such as engine, anti-lock brakes, or automatics. Cause most of the little code readers them gonna always have a system with them drop off it. So is either it can go in a transmission or them make it can do airbag. All of them can do engine. Well, most of them should be able to do engine, but them are drop off something major where you always have to have more than one of them. Cause them now gonna make it that it compete with the more elite ones. Cause it come out as a code reader. Enough you do nothing more than just reading a code. And I actually remember the cartridge scan tool. We did have a scan tool named Carman, where you use cartridge. So if I got scan like transmission, you have to change the cartridge. So some cartridges are now updated by downloading current specifications from a computer. So our replace cartridge nowadays is subscription. Yeah, update subscription, whatever, yeah. So you see how things evolve.
Yep.
Yeah. And I roll the cartridge, I think a game I can play. So most, yeah. So most manufacturers release new cartridge every 1 or 2 years. But the only good thing with them stuff here back then, even though I same thing nowadays still, where you could just buy the cartridge. But nowadays, some of them subscription fee where you have to update the scan tool every year. Some of them fee can actually buy back a scan tool, you know.
Yeah.
Because the RTL or wherever for update it is like 1,250 US. And the tool I sell for like $2,000. I say you can go buy a later version tool with the updates. So I say. But then you just buy a cartridge. But it's just that just like a Game Boy cartridge with them cartridges here, when them collect dust some of the time them not read. I remember we left here clean them several times. So the master right here said, do not touch the cartridge terminals. Static electricity could damage the electronics. And that is something with any chip too, a circuit board, and just touch it with a bare hand.
Yeah.
That's why I see most technicians use wear like a latex gloves or something like that. So troubleshooting cartridge. Hello, I think we need to go through these because we're not in the cartridge world anymore. But provides additional information such as normal sensors, values, and diagnostic advice. Data link connectors. So multi-pin terminal used to link the scan tool to the computer, sorry. OBD1 connectors came in various shape, size, and location. So as you can see, the OBD1, the system is just all over the place. Some it under the bonnet, under the dashboard, passenger dashboard. I was surprised if our OBD1 system is all under the vehicle itself. But then there's all over the place. And I like know where it located somewhere under the dash, whether it's the passenger side or on the steering. More standardized now, as I would say. So once a technician go into the vehicle for scan a tool, your car, him now fair wonder which part this thing there right now. Him a fair search. So if him charge, say that again.
Hello?
Yeah, Mayor.
I program key because I do program keys and stuff like that.
Oh,
that's my main strength here now.
Yeah.
And I still have to look all over the place still, but in a restricted area still.
Yeah. So them narrow down the area where you would have to search for.
We're not sure.
Yeah.
I tell you what I know, I tell you what over the other side. The Nissan them come all both.
Nissan they all both.
Yeah, Nissan they all both. They be money one of them vehicle, they are one place. Benz one place.
Yeah, man. So back then when you charge like by the hour for work per vehicle, you have to charge 1 extra hour to find the OBD link. Yeah. But the thing more simpler now, you know?
Yeah.
So, and if I'm gonna stop the class here, son, and pick up from here.
I appreciate those. It's a very good run through.
Yeah, man. Thanks.
Yeah.
Mr. Basic, I go jump in.
Yeah. That's good.
Yeah.
Evening, everybody.
Even service.
Well, every time I come up here, I apologize to late start, but I don't know what the system is. This social media thing.
Why don't we start at 8 then, since we almost start at 8 now?
but thanks for your patience still. I mean, we got it done. I mean, even with the best plans, something that's always seemed to come up. But nonetheless, with patience, everything worked out okay. I hope this session was really good and informative as the last. I know Mr. James is fired up to give you it all. I hope your brain can handle it. As I said, it is just the beginning, so there's a lot more to come. All right, I'm just gonna encourage you to, those persons who didn't get the outline, please indicate to me so I can send you the outline, the syllabus, so you can study ahead. I'm warning you again, this exam is not hard, but it is not a pushover. Please make an effort to read, all right? And if there are any questions that you think you could ask or suggestions that would improve what we're doing, because we're not perfect. If something you want to add, you can always make a suggestion, put it in the group, talk to us about it, it's all about making it better. All right, so thanks again for your time, your sacrifice. For those who are traveling, God go with you. And I hope you reach safe to your families. And we appreciate your time. So have a good night, have a good weekend, and we'll see each other again, God's willing, on Tuesday next.
All right, good night. Good night, Sir Basic.
Sir Basic.
Yes, listening.
Yeah, you see, the mention about travel safely.
Yes.
I'm going to remind everybody to just take it easy on the road now, please. And I'm charging the body for being a fast driver, but they can take it easy on the road to be a good help,
Yeah, especially it's a wet road now. This rain has been constant for a while now. So just be careful. Don't take any unnecessary chances. That's what the devil wants to do.
Yes,
Take
yes.
a chance and you know, reach your yard and your family's waiting on you. Accident mash up a lot of families, you know.
Yeah, man. It's very serious, man.
It really mess up a lot of families. So if you don't do it for yourself, do it for your family. If you're late already. All right, so just take your time and go in. So all the best. Have a good one. And we'll see each other again on Tuesday. Take care.
Yeah, man. Respect.
Show that now. Show me the slide over there. Screen.
Hold on.
That's orange. So there 20, slide 20.
Slide 20. Hold on.
Thing we teaching here, so when you're not mute. See that? Sure,